Alright, so now that we are familiar with the general modeling tools, we can go ahead and start talking about topology. So if this is the first time that you're going into the 3D world and you're interested in creating cars, robots, or environments, basically all of those objects are started right here. So this is the beginning of everything, and having a solid understanding and great foundation of topology is going to help you so much in your future projects. So what I'm trying to do here is we're gonna actually try and keep this very, very simple and just stick to the very basics, because this is a huge topic and we are going to talk about it more in depth later. But for now, let's just pretend that we are all complete beginners and we just need the basic explanation of what to look for, what is the difference between the two, and why the clean or good topology is important. All right, so what we have here on the left side is a clean and good topology, and here on the right side we have bad topology. So the difference between the two, the one on the left called clean or good topology is going to be easier to calculate, so it's going to be easily manipulated, meaning that it's very, very predictable in terms how you form your details and your shapes, and it's going to be easily deformed, and it's always going to look good on curved surfaces. And the one on the right basically has nothing of that. And to just set it into perspective, let's say you have a brand new car and you like how your highlights going through the let's say hood of a car or the door. So when you open the door and then you see the light going through that opening, so the movement will show the highlight, and basically there will be no lumps or bumps on that surface. As soon as somebody hits you, or by accident somebody, let's say with another car, comes and hits you in the door, it will be full of these little bumps, and basically you will see that via highlights. So the highlights will show you where the bump is, and this is the difference. So this is, let's say, the door of a brand new car, and this is the door that will show you the highlights of a car that has a bump in its doors. So to just, again, to see it and maybe even better in perspective, we will just now apply twist or bend deformers to each of them, and even though that they now look the same, the moment you deform, you will see what is the difference in the structure. So let's go to nonlinear, and I will just apply twist here, hit select this one, hit G to apply it again, and let's now twist this one, and let's see how the highlight behaves. So basically the highlight is going to be complete all the way, and there's not going to be any deformation on the surface. If I go to this one and apply the same deformation, you will now see that highlights will be broken, and that whatever we have, let's say this sort of close polygons together, a lot of edges going into one single point, from one point spreading aside, and then we have a one triangle here. Whatever we have, that you will see that we will get a break in that highlight. So basically this again is the difference between the two. Just very, very simple example. And now if you're, let's say, modeling a car or modeling a robot, you probably do not want to have those bumps on your model. You want to have it clean, and you want to have that surface very, very, very smooth, basically. So this is what our goal is. So what are we searching for here? So what we're going to do is we're going to always look for quads, and quads are polygons with 4 sides, meaning that they will have 4 points, and they will have 4 edges, and then they will form a quad. And this is what we're gonna search all the time. Whatever we do, we are always trying to form a quad, whatever we are doing. We are trying to avoid n-gons, and n-gon is a polygon with 1, 2, 3, 4, and 5 points or edges. So 1, 2, 3, 4, 5. This one has 5 edges. So this is what we are avoiding, and a triangle we are also avoiding for now. And a triangle has 3 points or 3 edges. All right, so now that we know what we are searching for and what are we avoiding, also a plus will be is that we are trying to organize our edges in a fashion that they have more or less even spacing. So as you can see here, all of the polygons are the same size. Sometimes they do not really have to be the same size. It's more about proportion and it's evenly spacing them out, because the more evened out they are, again, better they will deform and the better they will look on the curved surfaces. Here, what we have is a lot of uneven spaces. So small triangle here and then a quad here, and then it's very, very uneven. So this is again something else that we're going to search. So the more even out the topology or geometry is, the better it will calculate and the better it will deform. So what I mean is that we don't always have to search for even out. It's just important that we spread it out evenly. So again, maybe it's too confusing, but I can show you. So this also now goes into the topic that this topology is also very predictable, meaning that whatever I select to add an edge loop, you will see that this flow of edges and this flow of edges will just tell me that I can just simply add there a new edge without any problems, and I will just create new clean geometry on top. So if the foundation is good, anything that we create on top, as you can notice, it will still be very clean and organized. On the other side, if I try to do the same thing, so if I now try to do an edge, you will see that it will be all over the place, and it's going to be very hard to imagine where do I want to have my details. And the thing is, if I now start to continue add more and more geometry, it will become more and more messy. So it will just grow again exponentially. So if you have a clean geometry from the beginning, chances are whatever you build on top, it will still be clean. And let's now also talk about adding, let's say, details and, like I said, easily manipulated geometry. Is that now, for example, I want to add a detail here that has, let's say, this look. And the thing is, now I have here a polygon that is fairly large and here that it's fairly small. So what we can do is just even that spacing a bit. So this is also something that we're going to always try to watch out for, is just even that spaces and make sure that specific edge flow continues that flow. So think of it as a ripple. If you throw a stone in the water, and then the ripples that come from that, it will just slowly like fade out. And here we're trying to do the same thing, slowly just create that small fall off. And even though that let's say here they're still more or less in the same size. Now here they're a bit larger. So what we're gonna do, we'll always trying to find situations to fix that or add multiple edges. So now we added this edge right here, and even though that there is a triangle, but whatever there is a triangle and a quad, we can always fix that by simply adding another loop, and you will see that this loop will always stop on triangles. So this loop stops on triangle, and here we have a quad, and then it's going to continue. But if it stops on triangle right here, I will just middle click, go to vertex, and then we have a quad. So maybe it's not visible now, but if I maybe move this edge, actually I wanted to slide this edge, and if I want to slide this one, now we'll see that we have a quad. And if I select this, you will now see that we have perfect loop right here. And then if you want to, we can now create a detail, or we can add simply one more loop inside. So it's just going to be easier, again, easily manipulated and very predictable in what we do. So if I now decide, let's say, to add a detail here, I can simply do that like so. So this is what I meant, that it's going to be very, very easily manipulated. So maybe we can just go a few steps back and let me try extrude. Again, it's going to be maybe easier to see what we did. And there we are. So, but if you would like to do the same thing here, this is now going to be very, very difficult because we have no idea where this loop is and where to even begin. So like I mentioned, this one is going to be much more predictable than this one. So if you would need this detail here, what we would need to do first is clean everything up. So there's also one other thing that I would like to say. The better understanding of topology you have, it is going to be easier for you to break those rules and make them work your way. So for example, you notice here that both of the objects are exactly the same shape, but they act different on the formation. Meaning if you can create a shape, so if we're, let's say, creating a robot, and I just want to be focused on the shape first, and then later I'm going to think about topology. I can do that because we now, let's say, we have good understanding how topology is, so we know how to fix it. But if we're still in the learning process, it is just good to practice good topology first and then think about the shape. But in general, later, when you're a bit more experienced, we're going to think about the shape first and then, let's say, fixing topology later. So let's see how we can fix this. The way that I approach fixing topology is that I always remove things that I do not need and that are maybe not as crucial to let's say the curvature. If, let's say, specific shapes are affecting the curvature, then I would leave them. Actually, I would leave them, but if they are not affecting the curvature, I think I lost my train of thought. And anyway, what I want to say, if, for example, we have a couple of polygons that are affecting the curvature, I would maybe leave them and then rework around them. But if the damage is a bit higher, okay, so maybe what I wanted to do, let me add here insert edge loop tool, and then let's add how much edge loops that is. 1, 2, 3, 4, 5. So like that. All right, so now we have our topology back. Anyway, again, I lost my train of thought. What I was saying is that, like you've seen here, I removed everything that was basically here on the top. If we would have, let's say, situation, maybe I can actually go a couple of steps back just to show you, because maybe it's difficult to understand. Okay, so let me show you an example of what I mean. The form, let's go to nonlinear and let's bend this. So this is bending now like this, and we have a lot of deformation on the surface. And now we'll just look what is my main curve, and my main curve is this right here. And I can also notice that these edges are my structural edges because they are holding the curve. So them I would leave, and everything else I could remove. So meaning that everything else is vertical, and every vertical edge I can remove and then repopulate it back, and this I can leave. So I hope that makes sense. And we're going to do that right now. So because these edges are structural, I will not move them, because let's say we talk about curved surface, but everything here I can just simply double click and then remove and then repopulate it back later. And again, we're just now cleaning up the mess, and then we can bring this back. And now we have clean geometry again. And if we come here and apply the same deformer now, nonlinear, bend, now it will bend properly. We haven't touched any of the structural edges, and we just removed the ones that were, let's say, problematic, and then we brought them back in a proper way. And now that we have that, then we can focus in the same way like we did before. We can start playing and, let's say, trying to find interesting places where we can add details. Let's say something like that. We can add this little bevel here. do a small offset, add some thickness, and there we are. So now we have the same situation like we have here. So again, just in short, we are always searching for quads. We are always searching for ideally even out distribution of edges, and meaning that more or less that every polygon is the same size. It doesn't have to, but we are ideally searching for that. And it's simply going to be then easily deformed, easily calculated. It's going to look great on curved surfaces. So even now, if we come here and let's say I want to use bend deformer here. So let's use nonlinear, let's use bend. And actually I didn't, again, select that. And if we check how it looks subdivided, it is still going to look good on a curved surface. And if we by any chance have, let's say, not as good topology, we will just try to see what edges or which points are structural points and try to work around those. And if not, in many situations, it's just easier to rebuild the objects properly and then do the proper topology later. So again, this is just a very, very short and, trust me, very brief introduction in what topology is and how should we behave and what to look out for, but we're going to talk about it more in depth in future videos for sure. But for now, I'm going to close this topic and I'm going to see you in the next video.